meter square, and also the in this case air conditioning, for the air conditioning reverse again. So that will can be there's a light and power is a 50 volt per meter square. Office reverse again air conditioning 25 volt per meter square. This is for the office. And also for the retail shop, light power and the air conditioning. So there can be the every 70 light and power is 70 volt per meter square. Air conditioner 30 volt per meter square. So those are the tables you have to refer. So you have to refer the light and power for the office is 50 volt per meter square. And also the reverse air conditioning, we have to refer the 25 volt per meter square. And retail shop, light and power is 70 volt per meter square. Air conditioning is 30 volt per meter square. So those are the volt per meter square given for this kind of the installation. So in this case, this problem, we refer as raw data. And we substitute the data here. So for the shop, light power is the dimension 280 meter square and multiply with 70. So therefore, we multiply with 70 multiply 280. So you got the 1. So that's 19600 we got. This is both end. For the air conditioning, the dimension is 280 meter square and volt per meter square 30. So that we substitute. So the multiply 30 minus 280. So you got 84004 M. For the office light and power, the area is 250 meter square. Volt per meter square 50. So 50 multiplied 250 meter square, you got the 12500. And also the air conditioning, dimension is 250 meter square and then volt per meter square 25. So you multiply, so you got the 8250. So we add everything, all the things, so you got the 1795000 we got. So this is the thing we calculate for the test problem. So after you got this a short and office, so the maximum demand have to be calculated. So we calculate the maximum demand. So in this case, the short maximum demand is this one to the power, and office is this one. So the short maximum demand is 28000. This is the volt end. So divided by root 3 into voltage. So the voltage 400 volt line voltage. So we got the 91 ampere per phase. Also for the office maximum demand you add those days, you got the 189,500. So 18950 divided by the root 3 minus 400, you got the 28 ampere per phase we got. So this is the thing we got the thing. So in this case, which one is bigger? So we had to find out that so this is the in this case 41 ampere per phase. So in this case, cable size we can utilize 50 ampere, and also the 28 and 32 amperes HRC Q we have to utilize. So cable size and mean so 22 wise 32 ampere. This is the way we calculate it. The next one is how many 10 ampere socket outlets could be connected by the 2.5 millimeter square cable and 60 ampere circuit breaker in a non-domestic installation without permanent air conditioning. So this is the without permanent air conditioning. So how many 10 ampere socket outlets can be connected? In this case, the cable size is given a 2.5 millimeter square cable, and then we utilize a 60 ampere circuit breaker. So in this case, we have to utilize AS3000, table C9 have to utilize. So this is the table C9. We look at the table C9, AS3000 table C9. So this is the table C3. So go down, table C4, table C5, C6, C7, C8, and the C9. So we calculate the table C9. So this is the way where we use the table C9 here. So in this case, the size here is a circuit breaker rating and the cables are size. So given the two are given. So in this case, we refer to this table C9. In the problem, we use a 16 ampere and 2.5 millimeter square. So in this case, non-domestic installation. Non-domestic installation, 2.5 millimeter square and a 16 ampere. So here, 2.5 millimeter square and a 16 ampere. This one, non-domestic installation. In this case, you can connect the 10 ampere socket out in minus 2. And this is for the non-domestic installation without permanent air conditioning. If you connect the 10 ampere socket out there, you can connect the 2. But all domestic installation, non-domestic installation, and permanent air conditioning, in this case, you can connect this one number of the 10 ampere socket out there. And 15 ampere single phase multi-phase socket out there, you can install the 15. And also the 20 ampere single phase socket out there not applicable. Maximum connected load is up to 5,000 watt you can utilize. So this is the ways if you use a 2.5 millimeter square and circuit breaker is 60, those way you have to utilize. In this case, you only utilize a 0.5 as a lighting point. So therefore, this program, so in this case, 2 ampere per point you can utilize. So every point it can use a 2 ampere. This is a current rating. So in this case, the current rating is if you connect a 10 ampere socket outlet, so 2 ampere every point it can utilize a 2 ampere current. So therefore, the 2 ampere per point we can calculate it. So therefore, every socket outlet is 2 ampere. Okay, but circuit breaker rating is 16. So the 16 divided by 2 ampere, so you can connect the 8 point. So this is the way we calculate it. So non-domestic installation without air conditioning. Non-domestic installation without air conditioning. So this table, 2.5 millimeter squares are cable side and a 16 ampere circuit breaker. So the every 10 ampere socket outlet, it draw the 2 ampere. Every socket 10 ampere socket outlet is drawing the 2 ampere. So that we use a 16 ampere circuit breaker. So this 16 divided by 2, you got it. You can install the 8 number of the socket outlets. So this is the way we calculate it. In this case, if you use a lighting point, each lighting point is drawing the 0.5 ampere. So then how many lighting points you can install? So 16 divided by 0.5, you got the 32 points. But if the installation the permanent air conditioning, it will draw the 1 ampere per point. So that for the 16 ampere, so 16 divided by 1, you can install the 16 point. But 15 ampere socket outlet, it can draw the 15 ampere. So this is the it's drawing the 15 ampere. So the for the 16 ampere circuit breaker, you can only utilize one socket outlet. So this is the way we calculate it. In this case, total power can be installed is 5,000 watt. So this is the solution of this problem. A final circuit in domestic installation consists of the 5 single and the 6 double 10 ampere socket outlets. How many 10 ampere socket outlets could be added to this circuit when it is supplied with a 2.5 millimeter square cable and protected by the 20 ampere circuit breaker with air conditioning? So this means that in the final circuit, we include the 5 number of the single socket outlet and 6 number of the double socket outlet. So each got this 10 ampere. So in this case, how many 10 ampere socket outlet you can add? So this circuit is supplied with a 2.5 millimeter square cable, protected by the 20 ampere circuit breaker with air conditioning. So in this case, we also refer the same table. So the table C9 you have to utilize. So table C9 is given here. In this case, you can know about the 20 ampere circuit breaker and 2.5 millimeter square cable. So you see the 20 ampere circuit breaker, 2.5 millimeter square. So 2.5 millimeter cable, 20 ampere. So this is the here 2.5 and then 20. Cable side 2.5 millimeter square, circuit breaker side 20 ampere circuit breaker. In this case, if you install a lighting point, each light point will draw in the 0.5 ampere per point. If you install a non-domestic installation without permanent air conditioning, so each point taking the 2 ampere, and with permanent air conditioning, it will draw the 1 ampere So this is the given here. So in this case, you can see the 10 ampere single socket outlet. So that can be the how many socket outlet you can install. So 10 ampere single socket outlet is a 5 single socket outlet. So this is 5 number get already installed. 10 ampere single outlet 6 number double. So in this case, 6 multiplied 2, so 12. So this is the total 10 ampere socket outlet 17. This is the total socket outlet you is already installed is at 17. But how many socket outlet can be installed? So you can see that this is a 2 ampere. So this is the with the permanent air conditioning. So this is the 1 ampere per point. So the 1 ampere per point. So this is to the circuit breaker rating is 20. So 20 divided by 1, you got it 20 number of points. So the 20 number of points are you can install as a maximum, but it's already installed at 17. So that this is 20 minus 17, you get it and additional 3 points. So this is the we calculated. So this is the way we calculate this problem. So the 20 minus 17, you got a 3 number. And the next one is a 5 number of the double 10 ampere socket outlets. They are connected with the 2.5 milliampere square cable, protected by the 16 ampere circuit breaker and the office with permanent air conditioning. So this is the cable size is 2.5 millimeter square and circuit breaker size 16 ampere circuit breaker. So we install the 10 ampere socket outlet. So the 5 number of double 10 ampere socket outlet means you can see that all of these are you got the 5 multiplies are 2. So that way the 10 number is already installed. So 10 ampere socket outlet already installed 10 number. So then we have to add the additional how many additional point can be added. So that firstly we refer the table C9. Table C9 is a 2.5 millimeter square, 16 ampere. So you can see the table C9, 2.5 millimeter square, 16 ampere. 2.5 millimeter 16 ampere here. In this case, 10 ampere socket outlet, you can add this 1 number. So this is the 1 ampere per point. So in this case, we find out here 1 ampere per point. So the 1 ampere per point, so total ampere is 16 ampere because we use a 16 ampere socket outlet. So that you can use as a total number is 16 divided by 1. You can add the total number is 16 point. So total number already 16 point, but we already got a 10 number because of the double 10 ampere socket 5 number of the double 10 ampere socket 5 by 2 you got a 10. So the total is 16 minus 10 you got this as 6. So you can add the additional 6 point. So this is the we calculated. So additional 6 point we calculated this thing. And also the lighting point. In this case, lighting point you also have to calculate that. So lighting point is a 2.5 millimeter square, 16 ampere. So it's a 0.5 ampere per point. So the number of light can be installed. So in this case, this is about the additional cut available is a 6 ampere because of the 10 ampere socket already all socket outlets already taken the 10 ampere. So the total available is a 60 minus 10, so you got a 6 ampere left. So this 6 ampere is how many lighting point can be installed. So that you see that at this table. So lighting point calculation, this table you can see it. Lighting point is a 0.5 ampere per point. So every 1 point is drawing the 0.5. So the total current is a 6 ampere. So 6 divided by 0.5, you got a 12 light. So you can add another 12 light. So this is the way we calculate it. So this problem is firstly we find out the 2.5 millimeter square cable, 16 ampere circuit breaker. So the 2.5 millimeter square 16 ampere circuit breaker. So every one circuit break, one light, one socket outlet drawing the 1 ampere because of the across room that this cable singles are domestic installation. So that will be 2.5 and the 16. So that is withdrawing the 1 ampere by the point. So and then 16 divided by 1, you got a 16 point. So firstly, we got a 16 point. But how many point already installed in? We can calculate that. How many point you already installed there. 5 number of 10 MBR. So 5 minus 2, you got a 10 already. So 10 number. So this 16 minus 10, so you got a 6. So this is a left. Only 6 MBR is available. So this 6 MBR, we have to install the light wire. So how many light wire can install according to this table? Light wire is a 0.5 MBR per point. So 6 divided by 0.5 MBR point, you got the 12 number. So light wire you can add this additional will be the 12 number we can calculate that. So this is the things we calculated this problem. Okay, the next problem. A mixed circuit in the home has the 390 watts combined heat exhaust fan. So the mixed circuit in the home has a 390 watt combines exhaust fan and heater and the light. They are connected to this circuit. If the circuit is protected by the 60 MVR circuit breaker, how many 10 MVR socket outlet can be connected? So this will be the 2.5 millimeter square. This is for the given side and 60 MVR circuit breaker. So in this case, original load is a 390 point. So to the load is 390 point, so that this load is a 390 divided by supply voltage 230. So you got the 3 MVR already take out. And how many socket outlet will that? So that will be a 16 MVR minus 3, you got a 30 MVR. So 30 MVR is available for the socket outlet. So how many 10 MVR socket outlet can be connected? So you refer the table C1. Table C1 is, in this case, this one is a domestic installation because of the 10 MVR socket outlet. This will be the domestic installation. So this is we refer to the table C1. So table C1 is this is the table C1. We refer. Go up and we find the table C1.
Oh my God.
So table C1 here, this is table C1. So low group lighting point. So the first 1 to 20 point, it will take in a 3 MVR. Additional 20 point, it takes a 2 MVR. So this is the rule for the table C1. So this is the rule for the table C1. So the low group, this is for the 10 MVR, this is the lighting point. And for the socket outlet, low group is a B1. So the 10 MVR for the first 1 to 25, 5 MVR for the additional 25. So this is for the single domestic installation. First 1 to 25 is taking the 10 MVR. So therefore, this program, first 1 to 25. So this is for the current is a 15 MVR. So 15 MVR is we can add the installation up to the 40 point because 15 MVR means the first 10 MVR 20 point and another 5 MVR is also the 20 points. So total 40 points we can add that. So if this program current is now 30 MVR. And 30 MVR means so you can use a 30 MVR so the so 10 MVR is additional 20 points. But 13 minus 10 so that only the additional 5 MVR. So 5 MVR is unsafe because of the we need is 13 minus 10, so you got the 3 MVR left. This 3 MVR is not enough for to install the additional point because it need the 5 MVR. So there is safer to install the only 20 point. So this is for the that installation and those cables are we given. with this program, 2.5 millimeter square cable, 25 ampere circuit breaker, non-domestic installation without air conditioning. So how many lighting point can be installed? And how many 10 ampere socket outlet can be installed if the only socket outlet in the circuit? And if the 12 ampere allocated for the 10 ampere socket outlet and the 30 ampere for light, how many light and the 10 ampere socket outlet can be installed? So that if you install the only lighting point, so we refer the table C9 so that every light point taking the 0.5 ampere, so that there will be there will be 25 ampere circuit breaker, 25 ampere circuit breaker, 25 divided by the 0.5, you got the 50 light. You can install the 50 light. But only socket outlet installed. So this is for the without air conditioning. Without air conditioning, table C9 you look at. So this is the table C9. So this is table C9. Table C9 without air conditioning. So 25. So this is for the without air conditioning. This is for the socket outlet 2 ampere point. So 2 ampere point we can install. So this is for the 2 divided by the 25 ampere. So you got 12.5. So if we can install it up to 12 number of the 10 ampere socket outlet. And if you allocate the only 12 ampere socket outlet, so that this is 12 divided by the 2 ampere point, you can call it that 6 number of socket outlet. If you install it only 30 ampere for light, so each light light point drawing the 0.5 ampere, so 13 divided by 0.5, you call it 26. So here is a light point, we refer the 0.5. For the 10 ampere socket outlet, we refer this one because without air conditioning. Without air conditioning, 10 ampere socket outlet, every socket outlet taking the 2 ampere. Every light point is taking the 0.5 ampere. Therefore, this program, so how many light point will be required? So in this case, to the 13 by 0.5, you got the 26. And also the socket outlet, 12 by 2, you got the 6. So this is the way we calculate it. So this is the way we calculate for the this program. So this program means that you are provided with the cable side and also circuit breaker. So based on your cable size and the circuit breaker, how many light point, how many socket outlet can be installed. So the condition will be that with air conditioning and without air conditioning. Therefore, we refer the table C9. So table C9, you can see the cable crossing the area and the rating of circuit breaker, lighting point, we refer to this column, and 10 ampere socket outlet without air conditioning, we refer to this column, and permanent air conditioning, we refer to this column. And if you are installing a 15 ampere socket outlet, we refer to this column. 20 ampere, this column. So this is the way we calculate how many socket outlet and also light point can be installed. So the next way, the installation condition. So when you want to install the electrical installation, important one is that you have to find out the current rating capacity. So current rating capacity is the maximum continuous current that is the particular cable can carry without overheating. So this is for the meaning of the current rating capacity. This is the meaning of current carrying capacity. Current carrying capacity is maximum continuous current the particular cable can carry without overheating. So that current carrying capacity influenced by the ambient temperature. Ambient temperature is surrounding temperature, and also the type of cable, also installation. So that in this case, V75 that you can utilize 75 degrees centigrade up to utilize. V90 is that we use a temperature is 90 degrees centigrade, and V110 is 110 degrees centigrade. So that is a kind of the cable. Those kind of cable also influence the current carrying capacity. In the meantime, we also need to concern about the installation method. Including air, in this case, we will refer the air 3008 table 31, and including air table 32, are enclosed in underground. Table 3 and are enclosed underground is a enclosed underground in 3-4. So those table we have to the part. So those are kind of this are installation, type of installation, current carrying capacity, and ambulance ambient temperature. All are the affecting the current carrying capacity of the cable. So this current carrying capacity is maximum continuous current that a particular cable can carry without overheating. So that in this case, we also have to find out the, depending on the installation condition, table 3-1, 3-2, 3-3, 3-4, utilized to the determine the size of the cable. In this case, the 3-5 mean that we install the cable in this way. Late flat is as a touching in this way we can install. Late flats are separating is this install, this kind of installation. This is the 3-5 or late flat touching or late flats are separation, the way to install the cable. Now, of course, remember that the power cables are linked to the table 3-1, 3-2, 3-3, and 3-4. So in this case, we have to determine the cable size. Also, we can need to calculate the cable voltage drop. In this case, we have to refer the ASR 3008. Table 40 to 50 is utilized to calculate this voltage drop, and also the derating factor. The derating factor indicated by those are tables. So the derating factor and the voltage drop calculation, cable size determination, they have to the calculation process. So by referring the table 3-1, 3-2, 3-3, 3-4, we have to determine the cable size. We need to determine the voltage drop by using the table 40 to 50, and also we have to determine the derating. So this is the way we have to calculate. Okay, so that we have to solve this problem. A three-phase single core cable can enclose in L. V75 PBI cable is supplied at 25 ampere. So this is the enclosed in L. V75 TPI cable, thermoplastic insulated. It is supplying the 25 ampere. So we have to determine the cable size and also voltage drop. So the cable is at 42 meter long. We need to find out the voltage drop. So in this case, enclosed in L means we have to repair the cable 32. So table 3-2 have to repair. So 3 single core cable, it does not say about the insulation. So therefore, the 3 single core cables are insulation, so that we have to repair the AS 3008. So in now we are using the AS 3008. So that I open the AS 3008. So AS 3008 table, we repair the tables are 3-2. This is the AS 3008 table. Then we use a table 3-2. So go down. We look at the table 3-2. So table 3-2 is here. This is table 1. So we look at the table 3-1, 3-2. This is table 2. Table 3-1. Table 3 are enclosed in air. Table 3-2 is enclosed in air. Table 3-2 is enclosed in air. So this is one. So 3 single core cable. So the problem given the 3 single core cable, so it does not mention about the insulation. So we have to repair the item number 2. So item number 2 is this one. Item 2. 3 single core cable. It does not mention about the insulation. So the including this one 3 single core cable. So in this case, table 7-8, column 52-17. On the table 9, column 11-12. So in this case, V75 is at table 7, and V9 90, and then this one, and then V110 is at table 9. So this is the wave that we have to repair the cable. So this is the angle. So Table 7 for the 75 degrees centigrade, table 8 for the 90 degrees centigrade, and the table 9 for the 110 degrees centigrade. So in this case, we utilize a B75. B75, we refer to table number 7. So this is table number, column number 7. So this one is a column B75. Now, table number 7, you have to refer. So the table number 7, column 15 to 17. Because table 7 for the B75, table 8 for the B90, and table 9 for the B100, B110. So this problem is given as a 75 B centigrade or B75. So we follow the part to the table 7. Table 7, column 15 to 17. So that we look at the table 7, go down, table 5, table 6, and table 7. Table 7 is column 15 to 17. This is column 15 to 17. Column 15, 16, and 17 we in the last. So the column 15 for the copper solid stranded, 16 for the copper flexible, 17 for the aluminum. So that this problem, it does not give an answer. We assume that they're solid stranded. We don't use the flexible in the installation. We don't use the aluminum. Based on this, we use the copper we utilize. So the copper solid stranded, so we refer the table number 15. So table number 15, we have to refer. So this is the which table you have to refer. So the nouns are we utilize the table number 15. So in this case, we also have to calculate the cable side. Cable side, so the solids are stranded cable utilized. So in this case, how many current is given? So this is the supply of 25 ampere. So current requirement is 25 ampere. So current requirement 25 ampere. So that you can look at here. So the 21 ampere is a small, and so the 28 ampere is the better because of the this solid stranded are given. We utilize 28 ampere. So that in this case, we utilize that 4 millimeter square. The cable size is 4 millimeter square. Therefore, we utilize the cable size 4 millimeter square. So this is the way we calculate cable size 4 millimeter square. And then we also have to utilize the body draw. So body draw is a way to refer the table 40, 41, 42, 43, 44, 45 up to the 50. So those are table utilized to calculate the body draw. Table 40 for the copper single go 35. Table 41 for the copper single go, and so that's way and the wiring enclosure. Table 42 for the copper multi go. Table 43 is the similar to copper single go 35. Table 44 for the table 43 for the aluminum single go installation 35. Table 44 for the aluminum single go in the wiring enclosure. Table 45 for the aluminum multi go. And 46, 47, 48 are for the flexible cable. 49 is a MIMS cable, and the 50 is an area cable. So this is the ways depending on the kind of the installation, you have to select the appropriate cable from the 40 to 50, depending on the your installation. So this installation is how the cables are utilized. So there will be enclosed installation. 3 single go cable enclosed in the air. So this is 3 single go enclosed in air. So therefore, we refer that this cable is which cable you have to utilize. So so enclosing air, we have to refer the table 41. 3 single go cable enclosing air. Because of the 3 single go cable enclosing air is appropriate table 41. So that we find out the table 41, and also the temperature is 75 degrees centigrade. Size is 4 millimeter square. So we look at that table 41. So Go down, we look at the table 41.
Checking finance now with Stephen Dagley in the ComSec. Hi there, Steve. What helped push our market higher today?
Table 41. One in Nina way of Joe don't know, Table 41. Nino Lam, Senator Lamau, Low. Table 41. Table 41. So look at here, table 40 and table 41. So this is table 41 here. Table 41. So the size of 4 millimeter square and 75 degrees centigrade. So that there will be the 9/71. So this is for the VC value. The VC value have to be utilized in this formula. This is for this equation have to utilize this formula here. VC is a voltage drop VC Li by 1000. So this VC you have to utilize a millivolt ampere meter. We have to refer the table 40 to 45. And A is a length of the cable, I is a current. So VC you have to utilize. So this VC here, table 40 for the single core, table 41 for the copper single core enclosure, and table 40 for the copper multi core. 43, 44, 45 are the aluminum, and 46, 47, 48 for the flexible cable, 49 for MIMS, 50 for area. So this is for the VC calculation. So this problem cable size 4 millimeter square, 75 degrees centigrade with the part table 41. So with the part table 41. This is table 41. We apply it. 4 millimeter square, 75 degrees centigrade. So this is 9/71. So you use it 9/71. 9/71. This for the VC. And length is the 42 meter. Current is 25 ampere. So VC element 1000. We call it 10.2 volt. We calculate.
Australia's richest people for 2022 have been named.
So this will be the 19.2 volts we calculated. So the 10.2 volt is a voltage drop, and supply voltage. It must be the less than the 5% of the supply voltage. Supply voltage is 230 volts. 5%, 230 divided by 5%, we calculated is that will be the 11/5. So 11/5 is a so that we calculate is a 10.2 volts, less than the 5% of supply voltage. So this is the acceptable. So the next one is the three-phase voltage drop. Three-phase voltage drop and single-phase voltage drop calculation. So then, if you are using the single-phase voltage drop, is a three-phase voltage drop by √3, or the single-phase VC is a three-phase VC divided by 8/66. So that all the tables are 40 to 50. In this case, we got the three-phase VC. So this three-phase VC need to be divided by the 8/68. Then you can calculate the VC value. So that if problem usually you got the table 40 to 50. Those table 40 to 50 are for the three-phase VC is a given. So based on the three-phase VC, if the problem is a single phase, so the three-phase VC can be calculated converted to single phase VC by using this formula. And similarly, there is a single phase voltage draw and three-phase voltage draw relationship. Single phase voltage draw is a three-phase voltage draw by √3. Or the single phase VC is three-phase VC divided by 0.86. So this is the way. So from the table 40 to 50, what you got is a three-phase VC. So that if the problem is a single phase, you have to divide it by 0.86. So that this one is that if the problem is given in a three-phase VC table 40 to 50, we have to utilize directly But if the problem is a single phase, so that in this case, single phase body draw given, in this case, single phase body CBC is a 3-way divided by AC to be applied. So this is the way we calculate it. Okay, the next problem. 2 single phase socket outlet installed on the circuit provided by the 32 ampere circuit breaker, V75 TPI, and closing and non-domestic installation, then is a 50 meter. So we have to select the cable side, you have to find the voltage draw, and then we have to justify with the AR3000. So the 2 single phase socket outlet installed on the circuit provided by the 32 ampere circuit breaker. So the V75 TPI enclosing a non-domestic installation. That is a 50 meter. So we have to select the cable side, find the voltage draw, and justify with the AR3000. So the enclosing A. So this is the table 3.2 is a glass. But this is the job of you. You must check me out again. No. Enclosing A is a table 3.2 have to utilize. So that in this case, single phase is 2 singles are co-cable. So that in this is a table 3.2. Enclosing A. So table 3.2 is an enclosing A. Where do you utilize?
In 2008, Australia zeroed in. The Labor Party soon changed that. The Liberal Party continued the trend of excessive national debt, throwing out vote on the United Australia Party in Save Australia, authorised by Clive Palmer for the United Australia Party Brisbane.
Or 2 single go cable. 2 single go cable. So which one have to utilize? 2 single go cable. 2 single go cables are enclosing A. So in this case, which item have to utilize? So this 2 single go enclosing A. So item number 1. Item number 1, table 4, 5, and table 6. So table 4 for the 75 using rate, table 5 for the 90 using rate, table 6 for the 110 using rate. So those they have to utilize, table 4, 5, 6. So then, so you can see that this is a problem here. Table 4, 5, 6. So table 4 for the V75, column 15 to 17. So column 15 to 17. So then, in this case, current is a 32 ampere circuit breaker. 32 ampere circuit breaker given. So this is the table. Table 4 is a column 15 to 17. So table 4 V75. So table 4. This is for the 75 disintegrate. Column 15 to 17. So we look at the table number 4. Table number 4. Column 15 to 17. This is column 15 to 17. So the solid standard is for the copper. Flexible is copper is a solid standard for the column 15. Flexible copper is column 16 and aluminum column 17. So in this case, we use the solid standard and 4 millimeter square. 4 millimeter square. So this is the 32 ampere circuit breaker. This is 32. So then with cable side we use 4 millimeter square. So cable side we calculate the 4 millimeter square. So after that, we have to justify with the voltage draw. So the voltage draw is a we have to find out which cable have to utilize. So that will be the how this one installed. Cable 40, 41, 42, like this. So in this case, install on the circuit, no? Socket 2 single core. 2 single core is how the cable installed. You are here. This is copper single core and 3.5. Here is table 41 enclosed. So enclosed means you have to refer the table 41. Table 44 the copper single core. For that is 3.5, but the single core and enclosed is table 41. So this is in the wiring enclosure. Table 41 has been utilized. So table 41. From this table 41, based on the 4 millimeter square, you have to find out the VC. So the table 41, we look at, then we find out the VC. So the table 41, you go down, we find the table 41.
It is a grey night in store for Sydney with those showers and storms likely. Tomorrow we will see the rainfall ramp up a little bit.
So this is the table 41 we got. The table 41, 4 millimeter square. 4 millimeter square. So that will be there. This is the side of the cable here. And 75 degrees centigrade. 4 millimeter square, 75 degrees centigrade. So the V75 is 9 by 7.1. VC is a 9 by 7.1 we got. So you calculate VC 9 by 7.1. Millivolt ampere meter. So this is for the 3-phase VC. But this problem is given a single phase. Therefore, this VC has to be converted to single phase. So the 3-phase VC divided by 0.86 single phase. So 9 by 7.1 divided by 0.86, 11.2. This is the single phase. And then we did the VC 11.1000. So VC 11.2. Then on the circuit is already given the 56 meter. Current is at 32. So 56 and 32 and 11.2 divided by 1000, you got a 20 by 1. So the 5% of 230 volt, 5 minus 100 minus 230, 11 by, this one you got the 11 by 6. So the 20 by 1 answer not acceptable because of the greater than the 11 point, greater than the 5% of supply voltage. So this selection, we select the 4 millimeter square. This value we substitute. The value is more than the 5% supply voltage. Not acceptable. Therefore, we select the bigger side. Bigger side, you select you substitute the 6.49. 6.49 have to be substitute. Therefore, this 6.49 is substitute in this problem. This formula. So 6.49 substitute. This 6.49 by 8.6 is 7.49. So the VC by 1000, so 7.49 minus 76, PVC minus 32 by 1000, you 30 by 42. So there's voltage draw is a supply voltage 5%, 11 by 5, now 30 by 42, not acceptable. So we can select this 6 millimeter square. Therefore, you select the bigger side. Another bigger side is you select the 10 millimeter square. 10 millimeter square, you can substitute the 3 by 8. So this 3 by 8 substitute here. 3 by 8 divided by 0.8 is 4.45. VC by 1000 to 4.45 is a VC, A is a PVC, I is a 32 by 1000 to 7.49. So 7.497 volt is a less than the 5% of the supply voltage. So the acceptable, so that we select the cable 10 millimeter square. So in this problem, all those we select the cable by using the table 41 and tables are 456 and 4 millimeter square cable, but the by the adjustment with the voltage drop, this 4 millimeter square is not acceptable. Therefore, we have to select the bigger side. Therefore, when you select the cable side, firstly we select the cable side based on the current. But this is not enough. Accurately, when the cable is running low, it will draw the voltage. So that we also need to concern about the voltage draw calculation. Therefore, this problem, firstly we select the cable by using the based on the current, but this cable side is not enough by using by calculating the voltage draw. Therefore, we have to select the bigger and bigger cable. So that we calculate the voltage draw and compare with the supply voltage, compare with the 5% of supply voltage, and if the accurate calculation is more than the 5% of supply voltage, this cable side is not acceptable. So that we choose another bigger side and we recalculate again the voltage drop, and finally 10 millimeter square cable side, the voltage drop is less than the 5% of supply voltage. So that time it is acceptable. So 10 millimeter square cable is acceptable. So this means that this problem we can utilize the voltage drop calculation. The voltage drop calculation by using the current and also by concerning the voltage drop.
The race against time to find a 4-year-old girl missing in the Tasmanian wilderness. And historic fight, accused sex offender Gareth Ward becomes just the second MP in New South Wales history to be suspended from Parliament. Joe Biden arrives in Brussels for an extraordinary NATO meeting on Russia. The alliance now set to double its troop presence.
Wait, the next one will be the electrical trade practice. Page 14. Electrical trade practice. Electrical trade practice 2, page 14. So now we're talking about the standby power supply. Standby power supplies are generally intended to provide the main power at a specified load and when the usual main power is unavailable. So the standby power must be important, especially for the hospital, airport, and emergency installation, where to utilize the standby power supply. And also the circular movement losing the power is a crucial movement losing the power is the emergency intensive unit. If you lost the power, it will cause a loss of the light and the data. This is why that we have to utilize the standby power supply.
Its advanced technology gives you access
So
to more speed.
Momentary loss of power can be tolerated, and residential lighting on the residential socket outlet and daytime operation of the household and the essential electrical items. So those items require the standby power supply. Interruptible power supply is a connection here when the electrical load is associated with the device is supplying the essential electrical load. So when the main power supply off and then interruptible power supply is the switch go to the interruptible power supply and then it continues to supply the load. So UPS systems are attached to the battery, so and also the diesel driven generator. So this is about the block diagram of the uninterruptible power supply. Main supply it provides the AC, so that it provides a battery charger and a change to the DC, and batteries are supplying there's a DC to inverter, and then this inverter transform it to the AC and then supply to the load. In the meantime, AC is connected to the monitoring system. So that AC supply is a monitor, and then it can execute the chain over switch. So the permanently floating the chain from the input data. So in this case, we are using the PWM. Power modulators are utilized to attain the sideway output from the inverter. So therefore, the PWM inverters are utilized to produce the sideway. So this is the main supply here. AC supply to the load, or the battery. The AC also supply the battery charger, and batteries are connected to the inverter. At the time of this emergency, the inverter will supply the load through the chain over switch.
But if we all take better care of our clothes with the help of Vanish, which
so there are two kinds of this UPS, interruptible power supply. Offline UPS. So offline UPS is draw the current from the main supply and switch to the battery within a few seconds after depleting detecting the main power failure. So this is the offline UPS system. So the main power supply, so normally it's connected to filter and connected to load, and normally it's battery charging. So when the battery charger charge the battery, when the main power failure, so that inverter supply to the load. This is for the offline UPS system. Online UPS system is interactive UPS. So interact with the power into smoke out the waveform. So the main power supply here, so we provide a filter and connected to load. In the meantime, battery charger also supply the battery to the load. So the online UPS is an advantage. It can continually provide a clean power. So without it can only the automatic chain over switch by load. So the battery charger, battery inverter is supplying the load. So this is for the online UPS system. So offline UPS is a main power pay is supplying the load. Online UPS is continually supplying the load without whether main power pay or not, it's supplying the load. But when main power pay, the UPS stays supplying the load. So this is the online and offline UPS system. So this is the connection of the waveform. Inverter input is a DC and output will be the AC waveform. So that we use a solid state power supply system. We use the transformer, switching, indirect control circuit. So this is for the UPS system. So that you got the most FED driver. Also, this is a voltage limiter. So battery voltage limiter connected here, and most FED driver is driving those FED, and then the FEDs are making this switching waveform, and changing to the alternating current, alternating voltage, and the output is AC supply. So this is a connection of the FED circuit. So the inverter rating can be the continuous rating is a continuous power without inverter overheating. Half power rating is the oscillational application, and as share rating is a TV and a refrigerator. So this is for the surge rating is for the TV and the generator. So this is inverter rating. Normal waveform from the inverter is this is for the no square waveform. This is no good for the sensitive electronic equipment. Suitable only for the lighting. But modified sine waveform, and but this is a modified sine waveform. This is a fast wave pure sine waveform. So this pure sine waveform is good for the electronic equipment. So in this case, grid connected inverter is connected solar panel and connected to inverter, and this control sensor and connected to power load. So standby generator. Standby generator is a backup electrical system that operates automatically within the second of the main voltage, and the automatic transfer switch sense the power loss and command the generator to start and transfer the electrical load to the generator. So the standby generator is a backup electrical system that operates automatically within the second of the main blackout of the main power, and the automatic transfer switch sense the power loss, command the generator to start and transfer the electrical load to the generator. So this is the automatic transfer switch sense and main power loss signal and start the generator. So automatic standby generator application are utilized for the evaluator in the high-rise building, fire protection system, standby lighting, and medical light support system. So this is the utilizing of the standby power. So the factor for the switching of the alternator depend on the body current, frequency, power, and the power factor. So this is the main power supply circuit breaker. This is the connection of circuit breaker and standby generator and electrical load. So CB1 is manually operated. CB4 is manually tripped, and disconnections are non-essential load. Standby generator start runs to speed. CB2 is closed. This supplying power to the essential load. So this is for the changeover switch system. So this is for the feeder 1, feeder 2, and this changeover switch and connected to the load. So this changeover switch system. So the changeover system is this is for the feeder 1, feeder 2, and this is 40 ampere. This is 11 kV, 450 volts, 750 kV system, 1000 ampere load, and also automatic transfer switch. This is all connected load. This is standby generator. So this is the configuration of the feeder power transformer, standby automatic transfer switch, and standby generator. When the main supply lost, the control system sense the loss and operate the automatic transfer switch. In the same time, the standby generator started and then run up to speed. Once up to the speed, the standby generator then supplies the connected load. The control system will operate the appropriate circuit breakers to disconnect any non-essential service. So the type of the electrical converters are connected to the this is the uninterruptible power supply system. Also, we use the voltage stabilizer, motor generator, and the rotary inverter. Electricity converter must be installed with the independent isolation switch across the 4x12x4 of the ES3000. They must be installed with the independent isolation switch. So the electricity converters are the protection, the every sub made on the final circuit outgoing from the electricity converter must be individually protected and as an additional protection. So this is the cross 2x6 of the ES3000. So here will be the converter and load. They must not be adjusted by the PLC. Must not be bypassed by the PLC. So this is for the cross 4x12 and a 4x1. And RCD and electricity converter is we have to follow the 4x12 by 5x2x2 here 3000. RCD share every type of the switch for the waveform of the particular inverter. So other system is must follow the 4x12 by 6. Protected earthings are conductor shall not be switched. MVS connection remain intact. Earthing for the engine driven generator set must follow the ASR3010. Standalone power system must follow the AS4x09. Automatic voltage array, photovoltaic arrays must follow the ASR5033, and inverter system must follow the AS477. So this is for the appropriate Austrian standard to be comply with the standby power supply system. So standby power system are items to provide the power at the specified voltage and frequency. So UPS is an interruptible power supply system. UPS convert the DC to AC. And R2 conductor must not be switched. And standby generator requires the prime mover that is powered by the diesel engine, liquid phosphate gas, LPG, and natural gas. So this is converter and RCD. So RCD waveform must suit the inverter output. So there will be the difference between the inverter and the rectifier. Inverter is DC to AC conversion, and rectifier is AC to DC conversion. So the cross into there's a cross 7.3 incorporating the battery. So this is for the appropriate rule and regulation. Cross 7.3 of the year 3000 is main concern about the incorporating battery, and adding to the other side, we must refer to the section 5. In this case, this formula, kVA into 10 power 3 divided by 2, 400 volt, then we got the current. The current is, by using the current, we need to select the side of the protected relay earthing. So in this case, we might utilize a table 5x1. The overcurrent protection device must be located as close as practicable to the output terminal of the electric converter, so that the unprotected interconnection interconnecting conductors as a short circuit as a practicable. So the overcurrent protection device shall be located as close as practicable to the output terminal of the electricity converter, so that the unprotected inverter connection conductors are as short as practicable. So this is the 4x12 by 5x1. Independence isolation switch. Each electricity converter shall be provided with the independent isolation switch in crossing with the cross pipe 2x3 by 2x2. Electricity converter shall be arranged that it cannot supply the energy upstream of the point or the connection to the installation either directly or indirectly. This is the cross 4x12 by 3. So those are the appropriate AS3000 cross that's are concerned about the interruptible power supply. So electricity inverter must agree with the 4x12 4x1D, and this is the switch and connected to the main manual only switch and connected to the motor. So up to today's lessons, we're talking about the interruptible power supply. And the standby generator system. Now we're talking about the energy engineer workshop. Practical 3. Practical 3. So this is for the low tolerance measurement. Low tolerance measurements we utilize the vernier clipper or the microsa clipper. So this is the vernier clipper got the main scale and the vernier scale. So the every main scale got the 1 division got the 1 millimeter, vernier scale 1 division got the 0.02 millimeter. Similarly, micro clipper. This is also main scale and vernier scale. Main scale timber scale. Main scale got the 1 scale got the 1 millimeter, timber scale E1 got a 0.01 millimeter. So how to read? So firstly is you read there's a main scale value. So in this case, main scale value is multiplied with 1 millimeter. And then the vernier scale. So in this case, the vernier scale 0. Vernier scale 0 in line with the main scale. So this main scale value you have to read. And one of the main scale and vernier scale are exactly in line. So that vernier value you have to take. So this vernier value multiplied 0.02. And this is for the number 2. Number 1 is the main scale value indicated by the vernier 0. So this way, this is 1, this is 2. So 1 plus 2, you got the, by adding 1 plus 2, you got the reading of the vernier scale. So for example, this one is this problem here. In this case, main scale 0 is indicate the vernier scale. So vernier scale value is 37 multiplied 1 millimeter to 37 millimeter. And then main scale 7 and the vernier scale value 0.15. 33 by 1.5 is exactly on the line. So therefore, the 33 is multiplied with 0.02. So this is the 33 point is a vernier scale value is exactly with the main scale 7. So the 33 multiplied by 0.07, 0.66. So you add this two, you got the 37.66. So then this one you do the exercise. So this is for how to read the vernier scale. And also you do the low exercise. So in this case, this one is you have to read. So vernier scale 0 indicate the main scale value is 60.5. So this is 6. So 60.5. This is 0.5 1 millimeter. You got a 60.5 millimeter. And also the vernier scale and the main scale. The vernier scale 56 in line with the main scale. The 53 multiplied by 0.02, you got a 1.12. So you add this to 61.62. So then based on the explanation, you do the exercise. And also the how to read the micro clip bar. In this case, the micro clip bar. So the main scale in line with the timber scale. So the main scale is you see that this main scale value. The main scale value you see is a 4. So they multiply with 4. This is 4 millimeter. And then this timber scale, this is 5. So this is the timber scale multiply 0.1. So you got a 0.5 millimeter. So you add this to 4.55 millimeter. In this case, you also see there's a main scale value. Main scale value is you can see the main scale is a number 3. So you add a 3 millimeter. Timber scale 2. So this timber scale 2 multiplied 0.01, 0.02. So you add this to 3.02 millimeter. So this is in this case, the main scale 0, timber scale 0. So this is everything is 0. Here is a main scale 3, timber scale 2. So the main scale 3 you add, and timber scale 2 multiplied with 0.01 to 3.02, so 3.02 millimeter. This is the way you can utilize. So this is how do we use a timber scale and the main scale to do this various exact measurement. The next one is a life support CPR in the workplace. CPR is a cardiopulmonary arrest. So this is one of the scariest things and the most critical lives are threatening the situation. So sometimes people's heart is stopped because of the electrical shock and other reasons. So in this case, we must provide the CPR. The first 2 minutes of the cardiac arrest is very critical because of the when the heart stops, breathing, the body will start shutting down the brain, shutting down so that it can cause the brain damage, also organ failure and body cell failure, and the physical death can happen. Therefore, there's a first within the first 2 minutes, we have to provide the injury. So initial treatment of the injury is the first aid. And this is a professional remedy by the either qualified medical assistant or the practitioner. Alright, we must provide the first aid. So in this case, we have to provide the bandage for the bleeding, heart attack, electrical shock, and each of the blacking. So especially the first is sometimes you cutting hand or leg or body happen. In this case, machine tool, hand tools are cut the hand, legs and body. In this case, we must provide the bandage and lotion. Or choking by smoke, we must provide the air, the breathing, and burned by gas, hot water, electrical spark. In this case, burn treatment system must be applied. And also the radiation, we must provide the protection fall from the high, broken injury. So in this case, a tightening of the body parts to prevent the pala damage. So this is the way to provide the first aid. So in this case, DSR, these are action plan must be followed. D is a danger. Ensure that the area is safer for yourself, other, and the patient. I is a response. Check for the response. As the name, squeeze the shoulder. Is a nose response. In this case, stand for the head. In response, you have to make the comfortable and monitor the response. So you have to call the 000 ambulance and the other personnel, professional to arrive. It is an airway. So open the mouth, place a recovery position, and clear the airway with the finger. B is a breathing. In this case, check for the breathing, listen and feel. And it's a non-normal breathing. In this case, you have to start as a CPR. It's a normal breathing. You have to place in recovery position and monitor the breathing. So CPR means that you need to start the CPR, 30 chest compression and do breathing, and continue the CPR until the hair arrives. This is a defibrillation. So you have to apply a defibrillator and follow the advice prompts. The emergency procedure for the accident. Firstly, when the emergency happens, firstly you have to look around for the danger. So in this case, light electrical wire, light electrical component, explosion, flammable material, gas smoke, heat need to be checked. And also you have to remove machinery parts, you need to check. And well liquid and dangerous substance falling down from the object, you have to check. And also the check for the casualty response. You need to check the breathing, respond by the asking name, blood pressure need to check for the blood circulation. Also the cardiac arrest or not, you need to ensure bleeding of blood and broken bone and monitor the response and also the answering the call. Those things have to be checked for the casualty. After this, you have to provide the legal and the ethical issue and the duty of care. To avoid any lawsuit and any embarrassing situation, it's all the best to the license and seek the permission from the conscientious person to carry out any first aid. This means that you want to treat the one person, you have to take the permission from their relative or the nearby people. First aider should seek the legal advice from a lawyer or the legal practitioner. So the duty of care is the opposite to the negligence or the lack of care. So reasonable expectation to conduct your duty within your scope of the work or the responsibility that is both acceptable and equitable. So this is for the duty of care. Duty of care is for the very important for the health, safety, and the well-being of the employer and the employees. So that in this case, we had to follow the comply with the Occupational Health Safety Act and the other regulation. Negligence those are exercised and not care, which are sometimes result in the additional but the problems or injury to the other person. Duty of care is also the defending yourself. You need to provide the evidence that you have done a reasonable steps and the tasks to correct the situation. In this case, you have to present a wrong call diary and a full notice. The situation beyond your control and capacity is dangerous to execute the task. So in this case, you also need to show the evidence. It was impossible for you to assess the situation due to time factor and location. So this is for the name. So the CPR is a cardiopulmonary arrest, the effect on the body. So when the cardiopulmonary arrest happens, so that the failure of the ventricle or the heart to contract are usually caused by the ventricular fibrillation or the electrical shock with the absence of the heartbeat. So that when the heart stops, it can cause a significant decay in the blood function, decrease in blood function. So normally it's a lower vein, high is a pumping, there's a arteries, blood into the arteries. So that in this case, the output of the heart is a higher pressure. So that in this case, when there's a decrease in blood pressure happen, the pressure in the arteries and the vein will be equal within 15 seconds. In this case, termination of the brain electricity within 10 seconds. So that when the brain lost the electricity, brain oxygen deplete within 2 minutes, and the cell will damage and it can cause a death. Therefore, the point is so in this case, hypoxia means the deprive of the oxygen supply. After high stop it, oxygen supply will stop it. In this case, acid blood will be the acidic, so the build-up of the carbon dioxide in blood. So the heart is not pumping the proper oxygen. So the in this case, carbon dioxide will take place in the place of the oxygen, and the organ tissue can be damaged. So the CPR is providing the weight in the critical time, and it plus 2 minutes for the survival of the person. So that we have to manage the CPR and the vital function. When the person is unconscious, in this case, you have to check the mouth activity for any blockage for the anyway, and you have to check for the breathing, and any moment you check, if it's good, you have to call the 000. If they're not breathing, you have to provide a CPR. So this is the way to provide the CPR. Firstly, you have to open the mouth, and you have to provide the oxygen way. Then you have to do the CPR compression. You have to knee beside the patient, locate the lower half of the breastbone in the center of the chest. Place the heel of the hand on the lower half of the breastbone. Place the heel of other hand on top of the breast, and then interlock the finger and then raise the finger. Position yourself vertically above the patient's chest and press down the sternum to depress, and then release the pressure, and you have to do that 30 times to the 100 times per minute. So that in this case, the organ level of concession can happen. In this case, the lower oxygen level, heart and the circulation problem, and the metabolism problem, and the brain problem can happen. The sign and the symptom of the show are the fluid loss from the bone, intense pain, damage to heart, severe bleeding, spinal injury, the severe vomiting. So this is the colic flu, and the sweaty and the confusion can happen, and rapid pass and the vomiting can happen. So this is for the cause of the heart. So heart is not. So this is the ways in this lesson I have already explained about the how to provide the first aid and CPR. The first aid and CPR is very important for the emergencies rescue the person. Then we're talking about the video E26, E026. Okay, for the electrical diploma, so you have to go to the website. If you don't, I joined the college.com/electrical diploma 2022.htm, this website. And after the website, we have to go down, and you have to find this video lesson, YouTube video lesson for electrical engineer. This one. So this video lesson. Last week we have already finished E0 E26. So video 5 finished. So today we have to start the videos 6. Multiple integrate. So this one is so the lesson notes are here. So this, you download the highlightcomputer.com/video lesson.pdf, and then you have to look at the page 26 to 50. So this is a written note for the video. So this video are here. We start the multiple integrate.
But when Mitchell and Joey Manu come face to face for the first time since that ugly high shot last year, sparks are certain to fly.
It's quite a special guy, Joey. He's really clear on what matters.
So this is the ultimate integration. You have to
find the volume and region R divided by the parabolic cylinder, z equal to 4 minus a squared, the plates are a0, y0, yc, and z. So that this equation, z equal to 4 minus a squared. Z limit is a start from 0. So when you put the z0, so that z equal to 4 minus a squared, so 0 equal to the 4 minus a squared. A squared is 4, so a is a plus or minus 2. So limit is a start from the h minus 2 to 2. Y value is a 0 to 6. Z value is 0 to 4 minus a squared. So we write down the equation here. So integration, in this case, h limit is a minus 2 to 2, but we don't concern about the minus 2 because of the we want to find the area between the h0 and the h2. So the h limit is a 0 to 2, integration is 0 to 2, y limit is a 0 to 6, z limit is a 0 to 4 minus a squared, fz, dz, dy, and dh. So this is the multiple integral. So that in the place of the fz, we substitute 4 minus a squared, dy, dh. So the y limit is 0 to 6, h limit is 0 to 2. So that this is the integration differentiations are they cancel. So here you got the y. So a limit 0 to 2, 4 minus a squared y, limit 0 to 6 dh. So that we substitute that here. So the integrations are a 0 to 2, 6 into 4 minus a squared dh. So that will be as integration 0 to 24 dh minus integration 6 squared dh. So you integrate this one and put the limit, so you got the answer.
Well, it's still a tall order, but the Aussies have given themselves a shot at winning the deciding term test before.
A specky from the skipper. What a catch that was! Sensational.
So we multiply a cross b. So the denominator I is here 1102 minus 3 and 1. So firstly you see the I. So this column include the I, this column include the I. So neglect that, only this one you have to write. So the 10 minus 3 1. After the minus g, this column and this row neglected. So the 1201 has to write. For the k plus k. This column, these rows are neglected, so the 1 minus 3. So multiply this direction positive, this direction negative. So the 1 multiply 1 minus 3 multiply 0. So this direction multiply positive, so 1 multiply 1. This one will be negative, so minus 2 multiply 0 plus k. This multiply 1 multiply minus 3, that direction so 2 multiply 1. So finally you got the same thing. I minus g minus 5. So this is the a plus a cross b. The whole thing multiplied with cross b. So the I minus j minus 5k and the 4j minus 3 are multiplied. So the ijk here. So I minus 1 minus 5. I minus 1 minus 5. So this is no g I. So the 0, j is a 4 and the k is a minus 3.
Xavier Williams and Paul Gallen is the Captain Barry Palmer. The 45-year-old crashed into the canvas 3 times in the first round. The fight was stopped after just 2 minutes, launching a post-fight apology from Paul. Williams said Gallen might win. Graham Arnold is out of COVID isolation at Cricket West Australia against Japan.
And inverse plus and the differential equation. Okay, so we can further calculate the Laplace transform problem. So we have to find the inverse Laplace of 4s minus 3 divided by s squared plus 4. So the 4s minus 3 divided by s squared plus 4, we can separate. So that will be the 4s by s squared plus 4 minus 3 divided by s squared plus 4. So for the 4s by s squared plus 4, we can use as a cos omega t formula. Formula given Laplace inverse of the s by s squared plus omega squared is cos omega t. And therefore the Laplace inverse of the 4s by s squared plus 4, that will be the 4 multiply Laplace inverse s divided by s squared plus 2 squared. So that will be the 4 cos 2t. And similarly, Laplace inverse of the omega by s squared plus omega squared is sin omega t. So that we can write down this formula here. So Laplace inverse of the 3 by s squared plus 4, that will be the 3 Laplace inverse 1 divided by s squared plus 2 squared. So that will be the In this case, here must be 2 to use the formula. But we don't have the 2, so we multiply with 2, divide by 2. So we put the 2 and divide by 2. For to use the formula, there must be 2, because this is the numerator must be 2, denominator is the s squared plus 2 squared here. So if you can put the 2, you can use this sign formula. Therefore, we put the 2 here, divide by 2. So put the 2, divide by 2. So 3 by 2 Laplace inverse 2 by s squared plus 2 squared. Then we use the 3 by 2 sine 2t. Then we substitute a formula. So this is the Laplace inverse of the 4s minus 3 divided by s squared plus 4e squared to 4 cos 2t minus 3 by 2 sine 2t. This is for the Laplace transform formula. And similarly, we write down, in this case, this power is an integer. Integer means that 1, 2, 3, 4, 5. So we use it as a whole formula. But this power can be as a fraction number. Fraction number means that half, 3 by 2, 5 by 2. In this case, we have to use this formula. So this formula is the Laplace inverse of 1 by s power p squared to t power p minus 1 divided by the gamma function of the p. So in this case, gamma function p we can write gamma function of high is the square root of pi, and gamma function of n plus 1 is equal to n into gamma n. And therefore, the gamma function of the 3 by 2, what can you do is that 3 by 2 is similar to 1 plus half, so similar to the n plus 1 function. So then if you see the gamma function of n plus 1, n into gamma n, similarly, gamma function of half plus 1 is equal to half into gamma half. So the gamma half is equal to root pi, so the half into square root of pi. We use this gamma function and to find the Laplace transform with the power, fraction power. So that based on these equations, we use this solve this problem. We need to find the Laplace inverse of the 4 minus 5s divided by s power 3 by 2. In this case, s power 3 by 2 is a fractional number, so that we have to use the formula. So in this case, Laplace inverse 4 minus 5s by s power 3 by 2 can be separated. So that will be the Laplace inverse of the 4 divided by s power 3 by 2 minus 5s divided by s power 3 by 2. Then we use the 4 Laplace inverse 1 divided by s power 3 by 2. So that we use the formula here. So in the place of the p, we can use the 3 by 2. So then we use the 4 into t power 3 by 2 minus 1. Gamma function 3 by 2. Here is the numerator s, denominator s power 3 by 2. Then we use the 1 divided by s power half. So this is the 5 Laplace inverse 1 divided by s power half. So s power half, you use this gamma function. So that will be 5 into t power half minus 1 divided by gamma half. And similarly, Laplace inverse 1 divided by s power 3 by 2, we use the formula t into t power 3 by 2 minus 1 divided by gamma function 3 by 2. So in this case, here, 5 into t power half minus 1 will be there, t power minus half, gamma function half will be the square root of pi. Here, so t power 3 by 2 minus 1 will be the t power half, and this one will be the 3 by 2 is gamma function 1 plus half. So that will be the gamma function of 1 plus half will be half into gamma half. So that will be here the square root of pi. And this one is 5 t power minus half divided by square root of pi. So we go like this. So the final answer will be this 8 into t power half minus 5 into t power minus half divided by square root of pi. So this is we utilize the gamma function and together with the frictionless index to calculate the Laplace transform. So any power are frictional power, we have to utilize it. But if any powers are the integer, we have to use the previous formula. But this formula for this power with the frictionless number. equation we call is S square y minus 2s plus 1 minus 3sy plus 6 plus 2y is equal to 2 divided by s plus 1. So this is how we write down the solve the one. So this 2y plus 7, we only put as s square y and 3sy and 2y. So that all the thing include the y we put as the left hand side, and the terms without y we shift to the right hand side. So what you call is the s square y minus 3sy plus 2y is equal to 2 by s plus 1 plus 2s minus 7. So you combine means 2 plus s plus 1 multiplied with 2s minus 7. So we multiply. So what you call is a left hand side. Numerator will be there. 2 plus 2s squared minus 7s minus 7. So because of this 2s and this multiplied, so 2s and 1 multiplied, the 2s squared into 2s, and minus 7 multiplied s and minus 7s, minus 7 plus 1 with the minus 7. So left hand side this one, go to the denominator here, this one will be like this here. So the right hand side, left hand side only y, and right hand side will be this is the numerator and this is the denominator. So this denominator, this one you can get the factorize. S square minus 3s plus 2 can factorize. S square minus 3s plus 2 factorize is, so the s squares are factorized on s into s, plus 2 is a minus 2 into minus 2. So you make the cross multiplication, minus 2 and s is a minus 2s, minus 1 into s multiplying minus 1s. So minus 1s and minus 2s, you add to the middle term, you got the thing is a minus 3s. So therefore the you can factorize s minus 2 and s minus 1. So this denominator will be the s minus 2, s minus 1, s plus 1. So this one we can write a common factor. So a by s minus 2, a by s minus 2, plus b by s minus 1, plus c by s plus 1. So this is the right hand side. So left hand side b, you can represent by the right hand side. So this one you make the combine. So the s minus 1 and s plus 1 multiplied with a, and s minus 2 and the s plus 1 multiplied with b, s minus 2 and s minus 1 multiplied with c. So this one we call the p. So the a to s minus 1 multiply s plus 1 plus b, s minus 2 multiply s plus 1 plus c into s minus 2 multiply s minus 1. This is for the right hand side. And the hand side is this that 2s squared minus 5 squared.
យ៉ាងလေးရာကြီးထုတ်ထွက်သွားပြီ
Equate this this
။ရုရှားကထွက်ပြေးသွားပြီ
S
။ရုရှားကနေပြီးတော့ထွက်သွားပြီ
from here you got that all the A and C disappear, the B is the 4. S substitute minus 1, so A and the B disappear, C will be the 1 plus. If you substitute the S equal to 2, then we get B and C will disappear, only A is the minus 7 by 3. So then when you substitute A, B, C value, then we get minus 7 by 3 divided by S minus 2 plus 4 divided by S minus 1 plus 1 divided by S plus 1. So you find the inverse Laplace. So the minus 7 by 3 divided by S minus 2 will be there, minus 7 by 3 e power 2t. And 4 divided by S minus 1, inverse Laplace will be there, 4 into e power t. And 1 divided by S plus 1, inverse Laplace will be 1 into e power minus t. So this is the answer for this Laplace transform. So we can utilize the Laplace transform to solve the differential equation. Similarly, the electrical problem, we can use a similar method. So this is for the Laplace transform. We utilize the Laplace transform to solve the electrical problem. So A resistor of the R equal to 10 ohm and inductor of the A equal to 2 Henry and battery of the E volts are connected in series. Switch S,
ဟာ
at T equal to 0, the switch is
ဒီ
closed.
နိုင်မှန်းဆိုရင်
This
ဒီ
is
ထဲမှာ
closed.
တော့မရှိ
Switch
တော့
closed
ဘူး
and
ကျွန်
the
တော်
time
တို့
of the
ဒီ
T equal to 0.
သူရဲ့တို့ဆိုလည်းတရေတွေလည်းခဏခဏဖမ်းကြရ
Initially
တာ
this one is open
ဘုရား
and
ကြီး
then
ကျော်
at
စီ
the
ရဲ့
time T0
တော့
was
ဒီခဏ
5.
တက်ဝင်ပြီးတော့ရောက်နေတယ်
So the
the current is I equal to 0 because of the switch is was open before, so no current can pass through because the switch is off, so the initial current I is 0. So we have to find the current for the after switch off, you have to find a current. So supply voltage 40 volts. So this is for the supply voltage E, inductor and resistor connected in series. So the circuit current will be the I. So we write down the total voltage. Total voltage E is equal to the voltage draw across the inductor and the voltage across the resistor. Voltage across the inductor with the A diameter D, and voltage across the resistor with the I. A diameter plus II is equal to E. So in this case, A is our inductance value is 2 Henry, diameter D, current I, resistance is 10. So this will become the diameter D plus 5I is equal to 2 diameter D plus 10I is equal to 40. So the diameter D plus 5I is equal to 20. So the diameter D will be the I dash plus 5I is equal to 20. So we have to find the Laplace transform. Laplace transform I dash plus 5I, the hence side will be the Laplace transform of the 20. So that I dash, this is for the first order derivative, that will be the SIS minus I0, and 5I will be the 5IS. So Laplace transform of 20 will be the 20 divided by S. So initial current is 0 when the switch is off. Therefore, in the place of the I0, we put a 0. So what you call is the S into IS plus 5IS is equal to 20. So the IS multiply. So S plus 5 is equal to 20 by S. So the IA is equal to 20 by S into S plus 5. So this 20 divided by S multiply S plus 5 can be written the factor. So then we get A by S plus B by S plus 5. So we make the cross multiplication. The S plus 5 multiplied by A, so A into S plus 5. S multiplied by B into B into S. So then we get A into S plus 5 plus B into A is equal to 20. So we substitute S equal to minus 5. So A disappear, B is a minus 4. So S becomes a 0. So in this case, B disappear and A is equal to 4. So then we get 4 by S plus minus 4 by S plus 5. So we find an inverse Laplace. Inverse Laplace at 4 by S will be the 4B. Inverse Laplace at minus 4 by S plus 5 will be the minus e power minus 5. So this is the equation current I. The current I, after switch has been closed, the current will follow this equation. So based on the Laplace transform problem example, you have to study yourself. So topic 8, 9, 11, and 12. So A is the Laplace transform. So you study slide 1 to 13 and see the all are written on the whiteboard and the audio file and solve the problem 32 to 35. Topic 9, inverse Laplace, so slide 1 to 6, problem 31. Topic 11, gamma function Laplace transform, so slide 1 to and problem 32 to 35. And topic 12, Laplace transform in differential equation, so study the slide 1 to 14 and problem 36 and 37. And those are the fathers lesson, online lesson, and the exercise for the Laplace transform.
当然了，我就估计个多几样了。当然了，多一个不一个面呢。要算人家表面，那个我妈咪嘛，主要刚生的，哎，好点不啦？
高中。
这样子啊。
Okay, today lesson is a matrix.
妈让我看下人家是不放家有，今天点带你讲点点讲嘛，对呀。
This is at row 1. A1, A2, A3,
A3,
A31, A3. So this is the row 1 values are A11, A12, A13, A21, A22, A23, and A31, A32, A33. So that was the column. Columns are the column 1 is the A11, A21, A31. Column 2 is the A12, A22, A32. And column 3 with the A13, A23, and A33. This is the row and column. So the first reason you can add and subtract. So in this case, this value is the row 1, column 1 value. This is the row 1, column 1 value. So the row 1, column 1 value is the A need to be add or subtract with the row 1, column 1 value of the B. Similarly, the row 1 column 2 value of the A
H
H or subtract with row 1 column 2 value of the B. Similarly, row 1 column 3 value of the A can be H or subtract with the row 1 column 3 value of the B. So therefore the A plus B will be the 2 plus 3 and 1 plus minus 5, 4 plus 1, minus 3 plus 2, 0 plus 1, 2 plus 3. So by solving this one, you got the thing say 5 minus 4, 5 and minus 1, 5. 4A minus B, 2 minus 3, 1 minus 5, 4 minus 1, minus 3 minus 2, 0 minus 1, 2 minus 3. Therefore the A minus B is gone. And this is the transform. Transform means the row and column change. So row 1 value are the 214, that will be column 1 value. So the 214 row 1 will be column 1, 214. Row 2 value minus 302 will be the column 2, minus 3, 0 and 2. So that we use a metric to solve the equation with the many variables. For example, A11, H1, A12, H2, add to A1 and Hn is the R1, A21, H1, A22, H2, add to A2 and Hn is the R2, AM1, H1, AM2, H2, add to AM and Hn is the Rm. So this one you can solve by metric method. So the what we call is the A11, A12, A1 and metric, A11, A12, A1 and A21, A22, A2 and up to AM1, AM2, AM and metric, multiply with H1, H2, H up to H and metric is equal to right hand side R1, R2, Rm. So this is for the start. We use the metric to solve the equation. So metric can be multiplied. When you multiply, normally the row 1 and column 1 to be multiplied. Okay, so the row 1, first metric row 1 and the second metric column 1 to be multiplied, we put the disposition. First metrics are row 1 and second metric row 2 multiply with place at the that position. And first metrics are row 2 and second metric column 1 multiply, we place at this position. And first metric row 2 and second metric column 2 multiply, we are placed at this position. So the first metric row 1 is 214, second metric 324 is multiply. So this is a 2 into 3 multiply, 1 into 2 multiply, 4 into 4 multiply. All add together. And first matrix are row 2 minus 3 into 3 multiply, 0 into 2 multiply, 2 into 4 multiply. We place it here. And first matrix are row 1, 2 multiply 5, 1 multiply minus 1, 4 multiply 2. So you place here. And first matrix are column row 2, minus 3 multiply 5, 0 multiply minus 1, 2 multiply 2. And you add all together, the final answer will be the 24, 17, minus 1, minus 2. For the metric number.
တော့ဘာမှမလုပ်အမိတချမ်းပဲထောက်ဖို့လင်းကိုစစ်ကောင်စီမှာတွေ့တင်စတာအောင်နေတယ်အမိတချမ်း
We can also find a determinant of the metric.
1900
So metrics are minus 3, minus 2, 1, 2, minus 3, 4, 1, 2, the metric. So in this case, if you take the P, so that all the column and row containing the 3 is negative, the rest we had right. So that this column and this rows are called negative, so that 2, minus 3, 1, 2 can be read. Written. And second one with the minus, minus 2. This is 2 and this 2 includes all column and all row as negative. So you only have to write the 1, 4, minus 3, 2. 1, 4, minus 3, 2. And this is positive. So 2, the whole row and the whole column is negative. So 1, 2, 4, 1, 5. 1, 2, 4, 1. Then multiply with this is positive. So this is the 2 multiply 2 minus 1 multiply minus 3. Minus and minus with the positive. This direction multiply with the positive. That direction is negative. So the 1 multiply 2 minus 4 multiply minus 3. So this multiply direction with the positive. that one with the
ဒီ
negative
ဘာလဲတွေး
1
ဆိုင်
multiplied
တာ
1
တက်ဘောကောက်ကနေ
minus
တက်
2
ပြီး
multiplied
တော့ဘူးရောရှင်း
add all together to equal the 35. So this is for the determinant of the matrix. Trace of the matrix means that you only write the diagonal. So this matrix are 5 2 0 3 1 minus 2 minus 1 4 minus 1 4 2. So this will be the diagonal. You add the all diagonal value, then we get 5 plus 1 plus 2. This is the trace of the matrix. Cofactor means that for the 5, cofactor of the 5, so you have to neglect the all row and all column. Entry that pass through the 5. So that this is that this row, the whole rows are passing through the 5 need to be neglected, and this column, the whole column pass through the 5 need to be neglected. So only one we set is 2 minus 1, 1 0, 4 minus 2, and 3 2 1. So that way we just are the cofactor of the 5 is 2 1 4 minus 1 0 minus 2 3 2 1. The whole contents on the whole row, contents on the whole column that are passing through the 5 need to be neglected, only right there other thing. So this is the cofactor. Okay, so we want to solve the following equation by using the metric method. The equations are given as 3h1 minus 2h2 plus 3. 10h1 plus 2h2 minus 2h3 is minus 1. 4h1 plus h2 plus 2h3 is 3. So firstly we write down the metric. So the 3 minus 2, 2, 1, 2 minus 2, 4, 1, 2. h1, h2, h3. Right hand side will be the metric of the 10 minus 1 and 3. So that when you want the h1, h2, h3, this one, the whole thing have to be divided. Then will be the 10 minus 1, 3, and the inverse metric of the 3 minus 2, 2, 1, 2 minus 2, 4, 1, 2. So that this metric, 3 minus 2, 2, 1, 2 minus 2, and 4, 1, 2, we can write as an A. So A inverse is equal to AJKT divided by determinant. So this is the AJK is a transform matrix divided by determinant of the matrix A. So that I will explain later about the AJK transform matrix. Firstly, I will solve the determinant of A. So determinant of A is equal to determinant of 3 minus 2, 2, 1, 2 minus 2, 4, 1, 2. So you take 3, the whole row and the whole columns are neglected, so that you only write down 2 minus 2, 1, 2. And minus 2. So this is the first is the positive, second is the negative. Negative, minus 2. So the whole row, the whole column negative, only the 1 minus 2, 4 to right. 1 minus 2. And positive 2. This positive, the whole column, the whole row neglect. 1, 2, 4, 1 right. 1, 2, 4, 1. Then multiply with this direction with positive, that one will be negative. Also that this one multiply positive, that direction multiply with negative. So that this one positive, 2 multiply 2, and this one negative. Minus 1, 1 is minus 2. And that direction multiplication positive, 1 multiply 2, minus that direction. So 4 multiply minus 2. Here, that direction multiplication positive. So this is the 1 into 1, and that direction with the negative. So 4 into 2. 1 into 1 and 4 into 2. So that will be the we got the metric. So this is called 1 into 2 multiply 4 into minus 2, and this one with the 1 into 1 multiply 4 into 2. So this one is negative. That will be we saw that this one, finally we got the 35. Okay, now we write down the cofactor matrix. So AJK cofactor matrix is A11, A12, A13, A21, A22, A23, A31, A32, A33. We have already calculated the A11, A12, A13 value. So you substitute here. So then we get 7 minus 14, minus 7, 6 minus 2, minus 11, 2, 11, 8. This is the row 1, this is the row 2, this is the row 3. Then you have to transpose. Transpose means AJK transpose, AJK T. Row 1 become the column 1, row 2 become the column 2, row 3 become the column 3. This row 1, become the column 1. So row 1 7 minus 14 minus 7 become the 7 minus 14 minus 7 at the column 1. Row 2 6 minus 2 minus 11 become the column 2 6 minus 2 minus 11. Row 3 2 11 8 become the column 3 2 11 8. So this is the AJK transport. So A in Y is AJK transport and determinant A. So this is the numerator is the AJK transport. Determinant A we already calculated before. So the divide. So the entries are divided. So this is the A in bar. So the A in bars and the right hand side values are 10 minus 1, 3 values are multiplied. So this and this multiply. This and this multiply, this and this multiply, add together. This and this multiply, and this and this multiply, this and this multiply. So 7 by 35 multiply 10, 6 by 35 multiply minus 1, 2 by 35 multiply 3, and add together. Minus 40 by 35 multiply 10, minus 2 by 35 multiply minus 1, 11 by 35 multiply 3, and add together. Minus 7 by 35 multiply 10, minus 11 by 35 multiply minus 1, 8 by 35 multiply 3, and add. So the final answer will be 2, 3, and 1. So therefore the h1 is a 2, h2 is a 3.
မကြည့်လို့ရတယ်ပုံမှန်လည်းကြည့်လို့ရတယ်
This is the ways that we
ဒီကကိုလို့တင်တာ
to solve the unknown equation. So usually the metrics that we utilize
ဟောပြရလို့မဟုတ်ဘူး
solve the computer problem. Computer doesn't know that anything. That only the computer can do the things are programmed by the people, programmed by the human. So this is this step-by-step program. Is we got all this every equation will be different, but you can utilize the same method. The firstly, what we do is you find the covenant we will find the determinant metric, we transpose and multiply row, and then we got the answer. So this method is a general method to solve any kind of the equation, any number of the unknown equation by the computerized method. So the matrix solution is utilized to implement the computer solution for the three solve the unknown equation.
Absolutely. 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 Absolutely.